Okay, this is goal 2 for section 5.1 on operations with polynomials. Okay, first of all, we are going to talk about what a monomial is. I mentioned a monomial in goal 1, but the definition of a monomial basically is a product of numbers and variables. Now, the numbers need to be real. The variables can have exponents, but the exponents have to be positive integers. So an example of a monomial would be something like negative 5x to the 7th, y to the 8th. That would be an example of a monomial because it's a product. Okay, and then the exponents are positive integers or whole numbers, and the coefficient or the number in front is a real number. Okay, polynomials. Polynomials are a sum of monomials. So if you have multiples monomials added together or subtracted, then it's a polynomial. Poly means many, so you could have many of those. So an example would be like a quadratic that we've been dealing with. So like 3x squared minus 4x plus 2. That would be a polynomial because there are 3 monomials, which we also call terms, added together. Okay, so a monomial is also called a term. And so if you have more than one, this is called a trinomial, which is a polynomial because there's 3 terms added together. Now I know this is a subtraction, but adding and subtracting is the same thing, per se. All right, the degree of a monomial. The degree of a monomial is the sum of the exponents of the variables. Okay, so for example, in this one, the first one we have here, the degree of this is 15 because it's a 7 plus 8. You add the exponents in each term. The degree of this one is 2. The degree of this one is 1. The degree of this one is 0. Okay, because the exponent is 2, so that's a degree term that has a degree of 2. This degree is 1, and this doesn't have a variable, so it's like saying x to the 0 or 0 degree. The degree of a monomial, we just covered. The degree of a polynomial, such as this, is the same as the largest degree term of that polynomial. Since this one has a degree of 2, the degree of this whole polynomial is 2. Okay, because it's a second degree polynomial, which signifies quadratic. And so that's why a polynomial is the same as the largest degree term in that polynomial. Now, standard form of a polynomial we should know because standard form of a quadratic is ax squared plus bx plus c. Well, the reason a is first, or ax squared, is because that's the largest degree term. The next largest degree term is next, and the last largest degree term there. So when I look at this polynomial here, I've got 5 terms, or 5 monomials added together. I put the one with the largest degree first, which is the 5x to the 4th. That is the first term we should list in standard form. Next is plus 4x cubed. Next would be the minus 3x squared. Don't forget to transfer the minus down. Then it's minus 2x minus 7. That is standard form. Now, when it is in standard form, or not, it doesn't have to be, but what we also call the leading coefficient, which in this case would be 5, because when it is in standard form, the 5 is the coefficient of the first term. So the degree is 4, because the largest degree term is 4, and the leading coefficient is 5. Okay, so you should just know what degree of a polynomial is, and then how to identify the leading coefficient. Okay, well, let's do some examples. When you look at example 2a and 2b in the book, they say determine each expression is a polynomial or not. If it is a polynomial, state the degree of the polynomial. Okay, I didn't talk about necessarily what a polynomial is. However, I did mention that you first of all cannot have negative exponents. They have to be positive integers. So if the exponents are not positive integers, it's not a polynomial. If the leading coefficients aren't real, then it's not a polynomial. In this case, this is not a polynomial because y is in the denominator, or you've got 1 over y, or y to the negative first if you were to change it to that. So therefore, it's not a polynomial. The second one is a polynomial. And it says find the degree. Well, when I look at the degree of this one, the degree equals 6. This one, the degree is 7. This one, the degree is 2, because each one has one exponent. So you add those up, you get 2. So the degree of this whole polynomial is 7, because it's the same as the largest degree term. Common mistake students make is to add all of these, but you do not add them all. You only add the exponents within each term to find the degree of that term. The degree of the polynomial is the same as the largest degree term. Okay, 3a. Examples 3a, it says to simplify each expression. And this is where it comes in with being able to add or subtract like terms. Okay, so let's look at this. So if I wanted to add or subtract, in this case we're subtracting, but I could, if I wanted to, change this to a plus, but I would have to change the signs of everything inside. Change. Maybe you've heard that before in earlier grades, lower level classes. Change. If you change this to a plus, you could change every sign of everything inside. Now I'm going to add like terms. If I have a negative x squared and I'm adding another negative x squared, that's negative 2x squared. If I have a negative 3x and I'm adding a negative 2x, it's a negative 5x. I add the coefficients. Plus 4 plus a negative 5 is negative 1. And again, it's in standard form. It's a quadratic. Highest degree is 2. Blah, blah, blah. We could just keep going with all of that we just talked about. It's not asking for that. It's just asking for me to simplify it. This one here, I've got a 3x squared, but there is no x squared on this side, so the 3x squared is by itself. You do not add it to anything if it doesn't have another like term. This side doesn't have an x. This side has an x to the first. It does not have another like term, so it's just minus x. You cannot add the x squared plus the x. And then you have negative 6 plus positive 1 is negative 5, so that's simplified form. Okay? Hopefully that made sense. Now, the next set of problems is section or examples 4, and the directions on example 4 says write or find each product. Well, this is like the distributive property. We are going to distribute what's in front of the parentheses times everything inside the parentheses. If I multiply 4/3 x squared times 6x squared, that is 24/3 or 8x to the 4th. When you add or multiply exponents, you add the exponent, slow down. When you multiply bases, you add the exponents. you still multiply the coefficients. So 4/3 times 9. 4/3 times 9 is a 6. So plus 6, x to the third, because there's 3 x's when I multiply x squared times x. In this case, I have just 12 times 4/3. That would be a negative 16. This is wrong. The 6 is wrong. I'm going to go ahead and fix that. I don't know why I thought it was 6, but it's 12. So sorry about that. So I fixed it, and it should be good. 4/3, when you multiply everything times 4/3, you should end up with a little bit bigger number than what you started with, because 4/3 is higher than 1, and that's what I was thinking to myself. 6 times 4/3 should be just a little bit bigger than 6. 9 times 4/3 should be a little bit bigger than 9, and 12 should be a little bit bigger, so it's 16. Okay, the next one I'm going to distribute as well. This time I get positive 6a to the third. Negative 2a times negative 11a is positive 22a squared. Negative 2a times 20 is minus 40a. And that is simplifying when you're multiplying a monomial times a polynomial. Okay? With that said, I'm going to go ahead and I'm going to skip example 5 for now, but I'm going to go to example 6. So let me get this cleaned up so I can write those on here. All right, so 6a is x squared plus 4x plus 16 times x minus 4. So this time we're taking a trinomial times a binomial. Okay, 6b, we're going to end up with 2x squared minus 4x plus 5 times 3x minus 1. So same thing, just 2 examples of doing that. Now, when you take a trinomial times a binomial, you're actually doing like the FOIL method. You're taking each one of these times each of these. So each of these terms times each of these. I'm taking 3 terms times 2. I should end up with 6 terms when I'm done. So I end up with x cubed minus 4x squared when I multiply those first 2. 4x times x is plus 4x squared. 4x times negative 4 is 16, negative 16x. 16 times x is plus 16x. 16 times negative 4 is negative 64. So if you notice, I ended up with 6 terms. Now I'm going to be able to simplify possibly if I can add like terms. Since these two are like, negative 4x squared plus 4x squared, that's 0x squared. So basically, I end up with no x squared term. Negative 16x plus 16 is again 0. So I'm ending up with x cubed minus 64 when I'm done. All right. I'm going to distribute this one. I end up with 6x to the third minus 2x squared. Multiply this one. I end up with negative 12x squared plus 4x. And then I'm going to multiply the 5 times these, which is plus 15x minus 5. When I add these together, I end up with 6x cubed. That just comes down. Negative 2x squared minus 12 is minus 14x squared. 4x plus 15x is plus 19x, and then minus 5. So my answer is in simplified form, it's in standard form, and there's no like terms. So there is section 5.1, goal 2. Let me know if you need any help. Good luck.